Hi, welcome to my channel GCP Exam Ready. In this series we're going to go through everything you need to pass the Associate Cloud Engineering exam provided by Google Cloud. We've previously had an introduction into Kubernetes, but for this video we'll be diving deeper and having a look at the functions available to us. This is a picture that should be familiar to you from the video that we've previously done, Introduction to Kubernetes. In this picture, you can see the managed Kubernetes clusters and how they sit on operating systems that are on Google Cloud's data center. If you haven't seen that video, make sure you familiarize yourself before we move on. In this video, we're going to dive deeper. We know that managed Kubernetes clusters are part of compute resources. We also know that within Kubernetes, you have the option to have pods, services, volumes, namespaces. You can also have important keywords such as ReplicaSet, deployments, StatefulSets, and jobs. We will also be looking in the next video at deployments and monitoring. The first thing we need to go over are clusters. We've previously said we have master node and one or more nodes, but let's have a look at what those do. A master node is exactly as it sounds. It handles all the interactions that go through to the cluster. That means that you're going to be using a lot of Kubernetes APIs, as well as the kubectl control command. The future video will also go through introduction to command line and how you can use it to manage and deploy Kubernetes. Then, we know that you can have one or more nodes, and these nodes are responsible for having pods, and those pods are responsible for carrying out workloads. The workloads are carried out using containers. This is exactly why we call Kubernetes a container orchestration tool. What's a workload? A workload is any sort of job that somebody needs to do. These are organized and processed in Kubernetes clusters. I got this picture of Google Cloud's documentation. It has an overview of what Kubernetes looks like. So let's pretend we are a user right here. We can access and create clusters using the kubectl control command, as I said previously. What this does is it uses an API server which then can help control the cluster. This includes adding resource controllers, scheduling specific applications and using the scheduler, and it includes pulling in and pushing to storage. In addition to that, we have the master node and nodes which sit in the cluster. These use pods, and the pods contain containers as is shown here. You can have types of pods, you can have pods that run different applications, and you can have pods which run the same application. We'll get to this in a minute. The good thing about Kubernetes is you have all these services available to you, but you have more than that. And these are just ways that can help you to carry out the job you need to in the least amount of time. So you can have VPC networking, and this is an important networking concept. We've also given an introduction to this and we'll dive deeper into it as well. Then you can add persistent disks. We'll get into pods and how they're ephemeral. You can add a load balancer, and you can even have stack driver monitoring. None of this should be new to you. None of these cloud services should be new to you. We've previously discussed all of them. Let's have a look at pods. Pods are a core concept when you're working with Kubernetes. What's a pod? A pod is a single instance of a running process. What that means is it does one thing. It has one application. You can have pods which use and run the same application, and you can have pods which run different applications. Pods typically share a network, resources, and storage. They have a unique IP address, but they have a set of ports where you can plug the containers in. Again, as we've mentioned before, containers are isolated, which means that they don't depend on each other. We can have something called replicas, and this is important when you're working with Kubernetes. Replicas are copies of pods. They can be managed as a group. Again, as we've previously said, you can have groups of instances. You can also have groups of pods, replicas. Pods are ephemeral, which means they are going to be terminated. This means that if a pod is terminated, you can create a new one and you can delete one. This is all handled by the autoscaler and the controller. Now we'll have a look at services. Services are really important for applications that shouldn't be terminated. This means that this is situations where pods are just not good enough because they will be terminated. So the way you can think of a service is a list. It keeps a list of which pods are running which application. That way, if you need it, it can just reference it directly. That means you have the indirection of any application that depends on any other application. What's a replica set? Well, we've discussed what a replica is. A replica set is just a controller that ensures you have the right number of pods running. We've said before that replicas are copies of pods. Replica sets control those copies. They make sure that you always have the right number of pods. If you don't, simply these controllers can terminate pods. They can detect pod numbers and then they create new pods if you don't have enough pods running. This is set in your specification. A deployment. Deployments are sets of identical pods. When we say identical, we mean that they are running the same application and they're usually created from the same pod template. These pods run the same application and they're built off the same template, which means that they'll have the exact same configurations. These are definitely better suited for stateless applications where you don't care what the state of the application is. Opposite to that, we have stateful applications. This is where you need to monitor the state. You assign identifiers to pods for stability and monitoring, and then you have to know what state each pod is in to make sure that you always have the highest availability. Now we'll have a look at jobs. Well, a job is exactly as it sounds. You have a specification and you have steps that you need to take to meet the job. That means that your jobs will create pods and run them to make sure that any workload you have is completed. That means it's very important for you to set the right specification so that your jobs know what you're going to be carrying out in that workload. This has been GCP Exam Ready, giving you an overview of Kubernetes and all the keywords that are associated with it. I'll be posting new videos of Kubernetes with more detail that you need for the exam. I know this sometimes may seem like a lot, but I assure you that once you have the basics down, you'll definitely be able to ace that exam. Thank you for watching, hit the like and subscribe, and I'll see you in my next video. Good luck!